Genesis chapter 1 tells us that in the beginning God created the heavens and the earth. But the earth was formless and empty, and darkness was over the surface of the deep. And what this tells us is that God first of all created matter. And then after he created matter, he created energy. He said, "Let there be light." Now, the law of conservation of both matter and energy tells us that no one but God can either create or destroy matter. No one but God can create or destroy energy. You can change matter from one form to another. You can change energy from one form to another, but you can neither destroy nor create energy. Now, when God created the heavens and the earth, it was dark. Why was it dark? Because there was no light. You see, darkness is not a quantity. Darkness is not something that you can generate. You can't generate darkness. You can't move it from one place to another. Darkness just simply is the absence of light. Now, light you can generate. There's lots of ways you can generate light. And light can move. Light moves from one place to another. And light is a quantity. Darkness is not a quantity. Darkness is simply the absence of light. And light is energy. So darkness is the absence of light energy. Now, the same thing can be said about cold. In the same way that when God first created matter and he didn't create the energy, it was all dark. There was no light. And then he created the light and the darkness went away. Well, by the same token, cold is simply the absence of heat. Heat is an actual quantity. It is something that you can generate. Lots of ways you can generate heat. You can burn something. You can generate heat with electricity. Friction causes heat. If you rub your hands together, they will get warm. There's lots of ways to generate heat. Cold, on the other hand, is simply the absence of heat. So, if you're going to heat a house, it's a very easy thing to do. There are lots of ways to heat a house. You can light a fire. You can have a fireplace. You can have a furnace with gas. You can heat it with gas. Lots of things you can do. You can use solar power. The sunlight will heat the house. Lots of ways to generate heat and add heat to the house. However, if it's hot, then there is no way for you to generate cold. You cannot create cold. And you can't say, well, I'm going to move some cold from one place to another. Cold is just simply the absence of heat. So if you've got heat in your house is warm and you want it to be cool. The only way you're going to cool the house is to remove the heat. Let's say that this bowl represents your house and the water in the bowl represents the heat in your house on a summer day. Now, your house is full of heat, just like this bowl is full of water. That makes your house hot. You want to get rid of the heat. So if we want to get rid of the water, how can we get rid of the water? Well, we could just pick up the bowl and pour the water out. But I'm afraid you can't pick up your house and pour the heat out. That doesn't work. So what else can we do? We can take a sponge and we can drop the sponge in the water. Now notice the sponge is going to suck up water. Then we squeeze the sponge. And when we squeeze the sponge, we squeeze the water out of it. Now we drop it in the water again. Let it pick up water, absorb the water. Then we squeeze the water out. Drop it in and let it absorb the water. Then we squeeze the water out. Drop it in, absorb. Notice what's happening to the water level in the bowl. The water level in the bowl is going down. Now look at it. Look at that. Suck up that water. Now watch what happens. There's a little bit of water left. Watch what happens when I put that in there. See it suck that water right up? Okay, now guess what? There's no more water in the bowl. And so using the sponge, we were able to soak up the water and squeeze it out. An air conditioning system uses refrigerant like a sponge. Now, we have two different kinds of refrigerant that are commonly used in residential air conditioning systems. One is R22. That's the older refrigerant. It's a better refrigerant than the new stuff that the government is forcing us to use now. The new stuff is R410A. It's a zeotropic blend of three different types of refrigerant blended together. But here's how it works. This is called a condenser unit. The condenser takes the refrigerant that has come from the house. The refrigerant from the house has absorbed the heat, just like a sponge absorbs water. In the same way, the refrigerant in the house, in what's called the evaporator coil, has absorbed heat. The condenser unit has a compressor in it. This compressor squeezes the refrigerant. It compresses it, causes it to condense into a liquid. And when it does, it rejects heat. Just like squeezing the sponge will cause the water to come out of it, compressing the refrigerant causes it to condense, which squeezes the heat out of it. We say that it has rejected the heat. The refrigerant goes through the coils in this condenser, and there's a fan. The fan pulls air through the coils, which picks up the heat because the coils get very hot, picks up the heat and blows the heat out into the air. That's called rejecting the heat. So the compressor in the condenser unit squeezes the refrigerant and squeezes the heat out, causing it to become a liquid. Now, this liquid goes through what we call the liquid line. This line, the smaller line, this is a 3/8 inch line. It's called the liquid line. It's called the liquid line because the condenser has squeezed the refrigerant and caused it condense into a liquid. And it's taken the heat out of it. And it's shipping then this liquid line takes the liquid refrigerant into the house. This is the evaporator coil. Now, this is the liquid line going into the evaporator coil. The liquid line brings the liquid refrigerant that has had all the heat squeezed out of it and pumps it under high pressure to this right here, which is called a metering device. This metering device then has a small hole, an orifice, and it meters the refrigerant out through these little tubes to the coil. This causes the pressure to drop. That pressure drop causes the temperature of the refrigerant to drop dramatically, and the refrigerant gets very cold. That cold refrigerant now is a vapor. It comes in as a liquid, but once it goes through here, it vaporizes and becomes very cold. That vapor flows through these coils. Notice these coils, they go back and forth, back and forth, back and forth. And so that refrigerant vapor goes through these coils. And the fan pulls the air through the coils. And the air, and this air that's in the house, the cold coils absorb the heat from the air. So it's this refrigerant in this coil is like a sponge, soaking up the heat from inside the house. By the time it gets to the top here and gets ready to go back out, it is now a heated vapor. The vapor has now heated up, and it's because it's absorbed all this heat, and now it goes back to the suction line on the condenser. Now, this is the suction line, also called a vapor line. It is connected to the compressor inside the condenser unit on the suction side. The compressor is sucking the refrigerant. It's putting a low pressure. This is the low pressure line. This is the high pressure line. It's pulling the refrigerant out of the house, the refrigerant that has become a vapor, because it's low pressure, it's a vapor, and now when it gets to this point, it's a superheated vapor because it's absorbed all the heat from the house. And it is being sucked in to the compressor, which is going to compress it and then squeeze the heat out of it into the outside. This is the discharge line or the liquid line, and this is the suction line or the vapor line. This is the high pressure line, the small one. This is the low pressure line, the large one. Now, to recap, our air conditioning system is very much like a sponge. In the same way that we drop the sponge in the water to soak up the water, this evaporator coil is a sponge. It takes the refrigerant and it vaporizes the refrigerant, which makes it very cold, which causes it to soak up heat. And so this refrigerant soaks up the heat from the evaporator that's in the house, and the fan is blowing air from inside the house through these coils, which are very cold, and the coils are absorbing the heat from the house. It goes out and goes to the condenser unit, which sits outside. The condenser unit has a compressor in it, which compresses the refrigerant and sends it under high pressure through all these coils, which causes it to condense into a liquid. When it does, it gets very hot, and it releases that heat, which the fan blows air through the coils, taking the heat and rejecting it to the outside. So we have the sponge on the inside soaking up the heat, the sponge on the outside squeezing and releasing the heat to the outside. This is how air conditioning works. It takes the heat from inside the house and puts it on the outside of the house.
The narrative of Genesis chapter 1 indicates that God first created matter and afterward created energy. The matter was in darkness, meaning that there was no light energy. Then God said, "Let there be light," and energy was born. You cannot measure a certain quantity of darkness. You cannot generate darkness or move it from one place to another. Darkness is simply the absence of light. On the contrary, you can measure a certain quantity of light, which is a form of energy.
Cold is the absence of heat. What are some of the ways you can generate heat? Combustion, electricity, and friction. During a hot summer, there is heat in and all around your house, making your house too warm. You want to cool your house, but you cannot generate cold or move it from one place to another, because cold is simply the absence of heat. The only way to cool your house is to remove the heat.
This piece of equipment is called a condenser. The refrigerant vapor from the house, which has absorbed heat from the air in the house, is sucked into the condenser unit by the compressor. The refrigerant is squeezed by the compressor, which causes it to condense from a vapor into a liquid. When the refrigerant condenses, it rejects an enormous amount of heat, causing the condenser coils to become very hot. The fan pulls air through the hot coils, which absorbs the rejected heat and blows it out the top of the unit. After the heat has been rejected from the refrigerant, it is pumped under high pressure by the compressor back into the house through the liquid line, which is the smaller of the two copper lines connecting the condenser to the evaporator.
In this photo of a standard air conditioner line set, we see two copper lines going from the condenser into the house. The 3/8 inch line indicated by the number 1 is called the liquid line or the discharge line, and the 3/4 inch line indicated by the number 2 is called the vapor line or the suction line. The compressor in the condenser has compressed the refrigerant into a liquid, which has caused it to reject the heat into the outside air. This high-pressure liquid refrigerant is then pumped into the house through the liquid line to the evaporator, Once the refrigerant has traveled through the evaporator coils and absorbed the heat from the house, it travels back to the condenser through the suction line.
This is a photo of an evaporator coil from a standard air conditioning split system. The 3/4 inch copper line labeled number 1 is the suction line. It carries the refrigerant from the evaporator to the condenser. The 3/8 inch copper line labeled number 2 is the liquid line. It carries the refrigerant from the condenser to the evaporator. The part labeled number 3 is the metering device. It meters the refrigerant to the coil at the proper flow rate designed for the system.
The refrigerant in the liquid line is under high pressure. The suction line goes to the intake of the compressor, which is basically sucking the refrigerant out of the evaporator, causing the evaporator to be under low pressure. When the high pressure liquid sprays through the small orifice in the metering device into the low pressure evaporator, it flashes into a vapor, and the temperature drops dramatically. The now cold refrigerant absorbs heat from the metal fins in the coils, making the fins cold. The fan pulls air through the return air vent through the return air duct and blows it past the cold coils. The coils absorb heat from the air, making the air cold. This cooled air then blows through the supply ducts to the register or grills in each room of the house, cooling the house.
The refrigerant in an air conditioning system can be compared to a sponge. When the liquid refrigerant passes through the metering device into the low-pressure evaporator, it vaporizes it and becomes very cold. This cold refrigerant passes through the coils of the evaporator, soaking up the heat from the air in the house. The now heated vapor is pulled through the suction line into the condenser by the compressor. The compressor compresses the vapor, causing it to condense in the coils. When the refrigerant condenses, it rejects an enormous amount of heat, making the coils very hot. The fan pulls air through the coils, which picks up the heat, carries it away into the air above the condenser. This cycle absorbs the heat from inside the house and rejects to the outside of the house, cooling the house down.